After years of mystery, rumors, and theories, the James Webb Telescope finally revealed something that could change our perception of the universe forever. The first genuine image of the star Betelgeuse, which everyone thought was on the verge of an explosion. But what James Webb has captured surpasses all expectations. Now the question is, are we looking at a never-before-seen phenomenon, or is Betelgeuse hiding something even more incredible? Betelgeuse, one of the most enigmatic and gigantic stars in the firmament, has always intrigued researchers. Its enormous brightness and size, 1,400 times larger than the Sun, have inspired astronomers throughout the ages to observe it with both suspicion and expectation. The massive red star is a supergiant in the constellation Orion. But in recent years, something strange began to happen. Betelgeuse began to lose brightness, and many thought it was close to going supernova. A few years ago, astronomers noticed something surprising. Betelgeuse began to fade, and fast. For a star that shines so brightly, this phenomenon generated a wave of theories and assumptions. Was it dying? Were we about to see a supernova in our own galaxy? Expectations were at an all-time high. The variation in the brightness of Betelgeuse was so drastic that many really thought the end was near. A supernova visible from Earth would be an unprecedented event in modern history. That year was full of uncertainty. As data were collected, theories of the impending explosion became increasingly popular. But although the brightness changed, the explosion never came. Then came the James Webb Space Telescope, a marvel of human engineering, designed to see farther than we had ever imagined. With this launch, the world of astronomy received an unprecedented tool, capable of capturing details of the cosmos like never before. Equipped with a golden mirror more than 6 meters wide, the James Webb was created to observe the far reaches of the universe, but also to unravel the mysteries of our own galactic neighborhood. Betelgeuse became a prime target for this mission. Could the James Webb give us a clue as to what genuinely lies at the heart of Betelgeuse? Is it possible that we're looking at a phenomenon that defies the known laws of astrophysics? The wait for a concrete answer was almost unbearable for scientists. And finally, the image arrived, the first real high-resolution photograph of Betelgeuse taken by the James Webb Telescope. This image is not only beautiful, but it offers a new perspective on this red supergiant. However, it was not what scientists anticipated. Through James Webb's infrared eye, Betelgeuse not only appeared massive, but it also revealed a strange pattern on its surface, something that, until now, could only be guessed at. Scientists noticed that far from being a dying, dull star, Betelgeuse had hot spots and large bright areas, as if it were in full activity. These images showed that Betelgeuse is surrounded by a vast cloud of gas and dust that it released itself, and that violent explosions occurred on its surface, giving it a turbulent and changing appearance. This activity could be responsible for the variation in its brightness. With the James Webb image, the surface of Betelgeuse is known as a cosmic battlefield. Vast areas light up and dim in a matter of weeks, which is unusual for a star of its size. These explosions, called stellar mass ejections, can eject material in all directions, creating spectacular clouds of gas surrounding the star. This unpredictable and extreme behavior in Betelgeuse sparked several theories among scientists. Some think it is a sign that the star is about to enter its final phase, while others believe it may be stabilizing. But one thing is clear. Betelgeuse is behaving in a way we have never before witnessed in a star. What we see in Betelgeuse challenges our knowledge of stellar life. While we know the process by which a massive star dies, Betelgeuse's data suggest we may have been underestimating the complexity of this phase. The image captured by James Webb not only reveals details of a dying star, it also prompts us to consider cosmic timescales and our own place in the universe. If Betelgeuse exploded, the event would turn into a supernova visible from Earth for weeks, lighting up our night sky like a second sun, but without any danger to our planet. Although we are safe from any direct threat, the event could alter our understanding of the cosmos. The amount of energy released in such an explosion would be monumental and would offer astronomers a one-of-a-kind chance to study a supernova in real time. For scientists, a Betelgeuse explosion would be like seeing a spectacular, live astrophysics lesson. We could learn how these phenomena disperse vital components like iron and oxygen, which eventually form planets, and even life. The James Webb image not only illuminates the life and death of stars, but it also has crucial implications for the future of space exploration and science. Observing phenomena of this magnitude may reveal information about the formation of planetary systems and how the essential elements for life spread throughout the universe. In fact, many of the elements in our own solar system originated in stellar explosions of this type. Every atom of oxygen in our lungs, and every atom of carbon in your body, was forged in the core of a giant star. In a way, watching the end of Betelgeuse is like watching the end of life itself. As astronomers, it is a privilege to be able to study these events. They remind us that we are intertwined with the universe in ways we are still trying to understand. Every time a star like Betelgeuse dies, it gives rise to new systems, perhaps even new planets and life forms. The James Webb Telescope has not only given us an unprecedented view of Betelgeuse, its mission is just beginning. From distant galaxies to potentially habitable planets, the James Webb is designed to look farther than we have ever reached. What it has captured so far is just the beginning of a revolution in astronomy. The image of Betelgeuse is one of many wonders that Webb could reveal in the coming years. From star formation to the search for life, each observation represents an opportunity to unlock the deepest secrets of the universe. The James Webb is a window into the past and the future of the cosmos. Every image and every piece of data collected by this revolutionary telescope may rewrite what we all know about the universe, and perhaps one day even answer the question that has captivated us since the beginning of time. Are we alone in the universe? What do you think of this new image of Betelgeuse captured by the James Webb? Do you think we are about to witness the spectacle of a supernova? Tell us in the comments what you think of this discovery, and whether you want to keep up to date with the latest cosmic revelations. As the world digests this groundbreaking image of Betelgeuse, the implications ripple far beyond astronomy labs and observatories. Social media platforms buzz with speculation, awe, and curiosity. People across the globe are suddenly looking up at the night sky, trying to spot the now famous star with the naked eye, unaware that they are witnessing one of the universe's most volatile giants in real time. Educators and scientists alike are calling this a teachable moment, an opportunity to reignite public interest in space science, physics, and the mysteries of the cosmos. Schools are incorporating the Betelgeuse image into lesson plans, museums are hosting late-night viewings and lectures, and space agencies are accelerating collaborative missions to monitor the star's activity. Meanwhile, astronomers working with the James Webb Space Telescope are already planning the next series of observations. Using Webb's ability to see in multiple infrared wavelengths, researchers hope to study the internal dynamics of Betelgeuse with unprecedented clarity. One key question remains: what exactly is causing these stellar mass ejections? Are we witnessing a rare prelude to a core collapse supernova, or is Betelgeuse entering a mysterious new phase of stellar evolution, previously undocumented by science? Some scientists are even beginning to theorize that Betelgeuse may defy traditional classifications altogether. Its erratic brightness, chaotic surface, and immense mass loss may point to a star that is not just dying, but transforming. This possibility has sparked debates in astrophysics forums worldwide. Could Betelgeuse be part of a transitional class of stars that bridge the gap between red supergiants and other exotic end-stage phenomena such as Thorn-Isitko objects or magnetars? If so, Webb's data could rewrite textbooks and challenge long-standing models of stellar evolution. But for all its complexity, the story of Betelgeuse is also a deeply human one. It reminds us that even stars, those ancient, unwavering beacons in our sky, have life cycles. They are born, they live, they burn, and eventually, they die. And from their death comes life. The James Webb Telescope is not just peering into space, it's offering us a mirror. In the turbulent death throes of a distant star, we glimpse the conditions that once gave rise to us, and perhaps, someday, to others. Betelgeuse may or may not explode in our lifetime. But thanks to the Webb Telescope, we are closer than ever to understanding its fate. And in doing so, we're taking one step closer to understanding our own. So as you look up tonight and spot the faint, reddish light of Betelgeuse blinking in the Orion constellation, remember, you're not just looking at a star. You're looking at a question. A mystery. A story billions of years in the making. And we're finally turning the page. Wonders that the James Webb will continue to show us. Don't forget to subscribe, like this video, and activate the notification bell. Thank you so much for watching, and I'll be seeing you in the next video. Moreover, these innovations must overcome the limitations posed by missions in space, including the requirement for miniaturization, energy efficiency, and the ability to withstand the harsh conditions of space. Despite these obstacles, the potential rewards are enormous. Successfully observing and analyzing the atmospheres of exoplanets could lead to the discovery of biosignatures, chemical indicators of life such as oxygen, methane, or water vapor in specific ratios. These molecules might point to biological processes, suggesting that life exists beyond Earth. Researchers are also exploring ways to directly image distant worlds in greater detail. Future telescopes could be equipped with advanced adaptive optics, which adjust for distortions caused by Earth's atmosphere or the telescope's movements, resulting in sharper images. Combined with starlight blocking technologies, these improvements could allow scientists not only to detect exoplanets but also to map their surfaces and study their climates. The development of next-generation space telescopes marks a significant advancement forward in our quest to answer one of humanity's most profound questions: are we alone in the universe? By enhancing our ability to observe these distant planets, we are getting closer to finding out if life exists beyond Earth, potentially transforming our understanding of our place in the cosmos. The future of space exploration and the search for life beyond Earth is advancing at an unprecedented pace. As scientists and astronomers dive deeper into the mysteries of distant exoplanets, the James Webb Space Telescope is opening the data, ushering in a new era of cosmic discovery. It gathers data that assists astronomers in groundbreaking revelations about the structure, composition, and potential habitability of far-off worlds. And with each new piece of information, we edge closer to the ultimate question: is there life beyond our planet? Proxima Centauri B's discovery is just the beginning of what could become a major turning point in how we approach the study of extraterrestrial life. Being the closest star to our own solar system, Proxima Centauri has been a focus of intense research for years. However, until now, finding concrete evidence of life, such as artificial light or signs of civilization, was a dream for many scientists. The fact that such light has been detected by the Webb telescope only enhances the hope that one day we may contact other intelligent life forms in the universe. This kind of discovery stimulates scientific interest and public imagination, inspiring new generations to think beyond the confines of Earth. As the James Webb Space Telescope continues its observations, it's not only looking for artificial lights but also focusing on planet atmospheres, their chemical compositions, and how these factors could support life. The search for biosignatures like methane or carbon dioxide in the right concentrations is vital for understanding whether these planets have the right conditions for life. The Webb telescope has the ability to look at these atmospheric components in a way no other telescope has been able to, shedding light on the potential of distant worlds to support life. One of the most intriguing aspects of this entire endeavor is that we are observing history. The light from these planets takes years to reach us. This means that what we are seeing now actually took place years ago. Each discovery is a glimpse into the past, a cosmic time machine showing us what once was. So, as the data from the James Webb Space Telescope keeps coming in, humanity stands on the threshold of a new era, a time when questions that once seemed too far-fetched, like the existence of alien civilizations, might finally be answered. As more data is processed and new discoveries are confirmed, the excitement within the scientific community grows. Each new exoplanet detected, each atmospheric anomaly identified, brings us closer to refining the criteria for habitability. Scientists are beginning to create more sophisticated models to simulate alien climates and geological processes, helping us to narrow down the list of worlds that could potentially harbor life. One promising avenue is the study of so-called super-Earths, planets larger than Earth but smaller than ice giants like Neptune. These planets, which may possess dense atmospheres and stable surfaces, are becoming key targets in the search for biosignatures. With the help of Webb and future telescopes, astronomers hope to determine if these planets have conditions suitable for oceans, weather systems, and possibly even biological activity. Meanwhile, collaboration among international space agencies and research institutions is accelerating. Missions such as the European Space Agency's Ariel, NASA's upcoming Habitable Worlds Observatory, and the proposed LUVOIR, Large UV Optical Infrared Surveyor, are designed to complement Webb's findings. Together, they form a network of observation platforms that can cross-validate discoveries and provide continuous monitoring of the most promising targets. Public interest is also surging. Space documentaries, podcasts, and educational outreach programs are helping to translate complex findings into stories that captivate the imagination of people around the world. Students, inspired by the real possibility of life beyond Earth, are pursuing careers in astronomy, planetary science, and aerospace engineering. As technology advances, the dream of sending probes, or even robotic explorers, to distant star systems becomes less far-fetched. Though interstellar travel remains a monumental challenge, early concepts such as light sails and nuclear propulsion systems are being seriously considered. These innovations may one day allow humanity to move from passive observation to active exploration. But until then, we watch. We wait. And with every beam of ancient starlight captured by the James Webb Space Telescope, we inch closer to an answer. Are we alone in the universe? Or are we just beginning to hear the faint whispers of a cosmic neighborhood more crowded than we ever imagined?